Welcome to our online chemistry class. Our topic is alcohols, phenols and ether. Let us discuss physical properties of alcohols and phenol. Can you try this? Arrange OH, CH and NH bonds in increasing order of their bond polarity. So first of all, what is meant by bond polarity? It is depends on the electronegativity difference. If larger is the electronegativity difference, bond is polar. If electronegativity difference is same, bond is non-polar. For example, CH bond is non-polar, CC bond is non-polar because both these atoms of same element, they have equal electronegativity, so such bonds are non-polar. But if we consider CH, OH and NH bonds, these bonds in which one atom is hydrogen and another atom is different than hydrogen, they have different electronegativity than hydrogen. So more is the electronegativity of that atom as compared to other atoms in the respective bond, more is the polarity. So for this purpose, to decide the polarity, we must know the electronegativity of these atoms. So one simple rule is that as we move from left to right in periodic table, electronegativity goes on increasing. So carbon is least electronegative than among this pair. So carbon is less electronegative than nitrogen. Nitrogen is less electronegative than oxygen, because in this order these elements are placed in periodic table. So oxygen is most electronegative, that means the higher is the polarity in that OH bond, and carbon is less electronegative among these three, so less polarity in the CH bond, and nitrogen NH bond has in between polarity. So the increasing order of the bond polarity, CH is less polar, then NH, and then OH. OH has highest polarity in that covalent bond. Now next is the nature of intermolecular forces. So alcohol and phenol, both these are very polar molecule, and the reason behind that is the functional group dash OH. Both compound contain same functional group, and polar OH group are held together by one important bonding, and that is called as strong intermolecular forces, and the name is hydrogen bonding. So what is hydrogen bonding? It is bonding between two atoms in which one of the atom is hydrogen and another atom is more electronegative element than hydrogen, such as nitrogen, oxygen. Then the bonding between that hydrogen and more electronegative atom is called as hydrogen bonding. Let us consider the alcohol molecule. In alcohol molecule, the oxygen atom of first molecule and hydrogen atom of second molecule get attracted towards each other because both these molecules are polar molecule. The reason behind that is HO bond is polar because oxygen is more electronegative than hydrogen. So delta negative charge over oxygen and delta positive charge over hydrogen. So more electronegative part of one molecule get attracted towards the positive pole of another molecule, that is hydrogen. Similarly, you can observe the intermolecular hydrogen bonding between phenol. So the hydrogen bonding between two different molecules is called as intermolecular hydrogen bonding. So this is the important point for your physical property. Then next is the physical state. So lower members of alcohol family are colorless toxic liquids having characteristic alcoholic smell or odor. Pure phenol is colorless toxic and low melting solid having characteristic carbolic or phenolic odor. Why the word is carbolic? Phenol is found in middle oil acidic fraction of coal tar distillate. and due to its ability to neutralize common bases such as NaOH, it is also called as carbolic acid. So that word is used here. So phenol is also known as carbolic acid. Many time in your board exam question, this word carbolic acid is used instead of phenol. So due to this word, the odor is mentioned as a carbolic odor. Then next is the boiling point. The boiling point of alcohols and phenol increases with increasing their molecular mass. So if we consider the homologous series of alcohol family, methyl alcohol, ethyl alcohol, N-propyl alcohol or N-butyl alcohol. So here number of carbon atom goes on increasing. So molecular mass goes on increasing, and because every new molecule there is addition of CH2 group, molecular mass increases, and if you observe the value of boiling point value also increases. So this is the general trend you can observe for any homologous series. And if you observe the two molecules having same molecular mass, N-propyl alcohol and isopropyl alcohol, here what is the difference? Difference is that N-propyl alcohol is straight chain and isopropyl alcohol is branch chain. But if you observe their boiling point, molecular mass is same but boiling point is different. So branch chain alcohol or branch chain compound is having less boiling point than straight chain compound. So isopropyl alcohol has less boiling point than N-propyl alcohol. Similar trend you can observe in case of N-butyl alcohol, isobutyl alcohol and tertiary butyl alcohol. So if you observe their boiling point, N-butyl alcohol is 118, isobutyl alcohol is 108, secondary butyl alcohol is 99.5 and tertiary butyl alcohol is 83. All these temperatures are in degree centigrade. So in case of N-butyl alcohol, all the 4 carbons are in straight chain. In isobutyl there is one branch on one carbon of that chain, that is second carbon. In secondary butyl your OH group is on second carbon, and in tertiary butyl second carbon contain 2 branches. So more is the number of branches, less is the boiling point among them. So tertiary butyl alcohol has least boiling point among these 4. So branching increases, boiling point decreases. This is the general trend that you have to remember. Then next is, if you observe the solubility, phenols and lower alcohols having up to 3 carbon, means up to propyl alcohol, shows appreciable solubility in water. Again, the reason behind this is they can form intermolecular hydrogen bonding. So if you observe the higher carbon alcohol, this R group, that size of alkyl group attached to OH goes on increasing, so that interfere in the hydrogen bonding. So they do not form hydrogen bonding. So they are not soluble in water, or they are very less soluble in water. So such a type of hydrogen bonding we can observe in the lower member of alcohol and in case of phenol also. So one question is there, solubility of orthonitrophenol and para-nitrophenol is 0.2 gram and 1.7 gram per 100 gram of water respectively. Explain the difference. So if you observe the structure of orthonitrophenol and para-nitrophenol, this is orthonitrophenol. Within that same molecule, the hydrogen of OH group and oxygen of NO2 group, they get attracted towards, and there is a hydrogen bonding in the same molecule. That's why it is called as intramolecular hydrogen bonding. But if you observe para-nitrophenol, the oxygen of NO2 group and hydrogen of water, or hydrogen of OH group of that para-nitrophenol and oxygen of water molecule, they get attract together and the hydrogen bonding is obtained. But here these are the two different molecules, one is water, another is para-nitrophenol. So it is a intermolecular hydrogen bond. So due to such a type of strong intermolecular hydrogen bonding with water, solubility of that compound increases. So solubility of para-nitrophenol is greater, it is 1.7 gram than orthonitrophenol because stronger intermolecular hydrogen bonding. But in case of orthonitrophenol, it has strong intramolecular hydrogen bonding and therefore intermolecular attraction towards that solvent water molecule is weaker. That's why it has less solubility than para-nitrophenol. So this is about the physical property. Next point is chemical properties of alcohols and phenols. So let us see the first test, laboratory test of alcohols and phenols. First test is litmus test. So all are familiar with litmus. There are two types of litmus, blue litmus and red litmus. If blue litmus turns to red, solution is acidic in nature. So if we take water solution of these alcohols and phenol and if we add blue litmus in aqueous solution of alcohol, we observe that blue litmus does not change to red. That indicate alcohol is neutral in nature. While if we dip blue litmus paper in aqueous solution of phenol, we observe that blue litmus turns to red. This indicates that phenol has acidic character. But this type of acidic character is very less. So the reason behind that is, if you observe the reactions of phenol, it cannot react with weak acid such as sodium bicarbonate NaHCO3. So there is no reaction with NaHCO3, but it can react with strong base such as NaOH, sodium hydroxide, that we already learned in the method of preparation. Or if you observe the reaction, this is phenol react with NaOH and it gives sodium phenoxide and water. This is aqueous solution, and when this aqueous solution of sodium phenoxide react with hydrochloric acid, then we can again reobtain the precipitate of phenol and NaCl get dissolved in the water, means we obtain aqueous solution. So we can easily separate out the precipitate of phenol. So as your phenol does not react with aqueous solution of sodium bicarbonate, it is less reactive. So do you know sodium bicarbonate NaCO3, sodium hydroxide NaOH and sodium metal are increasingly strong bases. Weak and strong acids can be distinguished from this qualitatively by testing their reactivity toward this base of different strength. A weak acid does not react with weak base. For example, phenol does not react with Phenol is weak acid. It does not react with weak base such as NaCO3, sodium bicarbonate. It requires a strong base to react. So NaOH is required. So phenol is a weak acid. A strong acid can react with weak acid, weak base as well as strong base. For example, HCl is a strong acid. It can react with NaCO3 and it will give water, NaCl and carbon dioxide. And it can also react with strong base such as NaOH. It will give NaCl plus water. So strong acid can react with strong base as well as weak base, but weak acid cannot react with weak base. It reacts only strong base. And from this you can easily identify the strength of that acid. Similarly, you can check the strength of base. So alcohol does not show acidic character in its aqueous solution, so we can say that it is neutral to that acid. It shows neutrality towards the base, so it does not show the reaction with aqueous sodium bicarbonate and aqueous sodium hydroxide, NaCO3 and NaOH. So very weak acid character of alcohol can only react with active metals such as sodium. So when alcohol react with sodium metal, this hydrogen get replaced and it gets separated out as a hydrogen gas. So we get a species, and that is called as sodium alkoxide. And you can easily observe with liberation of this hydrogen gas in the form of air drop. So liberation of hydrogen gas is used to detect the presence of dash OH, means alcoholic group, in your molecule. So if you compare the strength of base, sodium bicarbonate NaCO3 is weaker base, NaOH is stronger base as compared to that, and sodium metal is stronger. So if you have to check the strength of your acid and base, you have to use, if you have to check the strength of acid, we can use these different types of bases like NaCO3, NaOH and sodium metal. Next is the characteristic taste of aromatic compound such as phenols. Phenols can react with neutral FeCl3 solution, ferric chloride. And what is the product? We get a product ARO thrice Fe. That means this 3Cl of FeCl3 get replaced by 3 ARO molecule, group, and we get a color like purple, violet or green, depends on what is the type of your phenol. So it is in general phenol class. It may be phenol, it may be naphthalene, it may be anthracene. So specific color is not mentioned. Plus HCl molecule is obtained. So if you take phenol, means C6H5OH react with neutral FeCl3, it shows violet color. But if you write the reaction of your alcohol with this neutral FeCl3, it does not react. So this reaction, action of neutral FeCl3 is used to check the difference between alcohol and phenols. So alcohol does not shows reaction with neutral FeCl3, but phenol can show purple, violet or green color with neutral FeCl3. So when near board exam, question may be asked, how will you write a distinguished chemical test between alcohol and phenol? So then at that time you have to write these two reactions and mention that alcohol does not react with neutral FeCl3, while phenol shows purple, violet or green color with neutral APCl 3. Don't write the regular distinguish point between alcohols and phenol, like alcohol is aliphatic hydroxy compound and phenol is aromatic hydroxy compound. Then next is the distinguish test for alcohols. So how will you distinguish between primary, secondary and tertiary alcohol? For that purpose, one specific reagent is used, and that is Lucas reagent. What is that Lucas reagent? It is concentrated HCl and anhydrous ZnCl2. So your primary alcohol react differently with secondary alcohol. Secondary alcohol react differently with tertiary alcohol with respect to your Lucas reagent. So let us see the reaction. So if you observe reactions of this alcohol with Lucas reagent, alcohols are soluble in Lucas reagent, but the product alkyl halide, here chloride, is not. So if we observe a clear solution, then it is alcohol, and if it turns to turbid, that indicates there is a formation of alkyl chloride, which is a product. So tertiary alcohol react faster than secondary alcohol. Secondary alcohol is react slower as compared to tertiary, and primary alcohol turns the reagent turbid only on heating. Means what is the reactivity of this alcohol towards the Lucas reagent? Tertiary is most reactive, then secondary alcohol, and primary alcohol is the least reactive. So when you have to write the reaction of this alcohol with neutral APCl3, with Lucas reagent, then for primary alcohol we have to heat the mixture, and in case of secondary alcohol we require anhydrous ZnCl2, but in case of tertiary alcohol it reacts only HCl. So this is about the reactivity of your alcohol with Lucas reagent. So if you observe preparation of ethyl alcohol, preparation of ethyl chloride from ethyl alcohol, you have to heat the reaction mixture HCl and anhydrous ZnCl2. If you have to prepare isopropyl chloride from isopropyl alcohol, then there is no need of heat. So simply you can add HCl and ZnCl2, then it can give the product isopropyl chloride. But if we take tertiary butyl alcohol, there is no need of anhydrous ZnCl2. Simply if we add HCl, and there is a product formation, tertiary butyl chloride. So we can check this reaction in halogen derivative. Now next is reactions due to breaking of OH bond. So acidic character of alcohol and phenols. So if you observe the aqueous solution of alcohol, it is neutral, while aqueous solution of phenol is slightly acidic, and the reactivity of these alcohols and phenols is towards the ionization of OH bond. because this ionization is different. The reason behind this is the stabilization of that ion produced after ionization of OH bond. So if we write the ionization of alcohol ROH react with water, it gives RO minus plus H3O plus, and again these two get combined together to produce your reactant back. So there is a reversible arrow, and this RO minus is unstable. What is the reason behind the instability of this RO minus alkoxide ion? The reason is the R group. R group has electron donating inductive effect. More is the R group attached to oxygen carbon, more is the electron flow towards the oxygen, and less is the stability of that negative charge over oxygen. So if you observe this question, arrange the following compound in the decreasing order of acidic strength and justify your answer. So there are 4 compounds: ethyl alcohol, tertiary butyl alcohol, phenol, and para-nitrophenol. So you have to arrange this compound in their decreasing order of acid strength. So first we'll check only first 2 because they are alcohols. So first alcohol on ionization gives, ethyl alcohol gives CH3 CH2O minus. Okay, so this is called as conjugate base, and we consider that alcohol as a conjugate acid of this pair. So negative charge over oxygen, and if you consider the second molecule is tertiary butyl alcohol, negative charge over oxygen. If you consider the carbon attached to oxygen, so here one alkyl group is present, but in case of tertiary butyl alcohol, the tertiary butoxide ion, 3 alkyl groups are there. So number of alkyl group attached to carbon goes on increasing. So the negative charge is unstable. So electron donating inductive effect plus I effect of alkyl group destabilizes the alkoxide ion, that is the conjugate base of alcohol. So as a result, alcohol does not ionize much in water and behave like neutral compound in their aqueous medium. But if you observe the ionization of phenol in its aqueous solution, phenol react with water gives phenoxide ion by loss of this H, and it was gained by H2O. So we get C6H5O minus, that is known as phenoxide ion. This is stabilized by these 5 different resonating structure. So if you observe structure number 2, 3, 4, oxygen, which is more electronegative atom, does not carry negative charge. So this negative charge is transferred through this benzene ring and again comes to that oxygen in the 5th structure. So the negative charge is stabilized by this 5 different carbon, 5 different carbon in the benzene ring at its ortho and para position. So phenol ionizes in aqueous solution to a moderate extent and thereby showing weak acidic character. Now again we comes to our question. Here phenol is present and para-nitrophenol is there. So if you observe para-nitrophenol, one more extra resonating structure is present. Okay, so here if you observe structure number 3rd and 4th, this oxygen shares that negative charge. So if you observe the structure number 4, this oxygen carrying the negative charge. So one more structure is involved in the stabilization of that negative charge. So if you compare the acidic character of phenol and orthonitrophenol, the conjugate base of paranitrophenol is better resonance stabilized due to 6 resonating structure as compared to 5 resonance structures of conjugate base of phenol is present. So the resonance structure 6, if you observe this 6 structure, negative charge only on electronegative atom. So oxygen carrying negative charge, here also oxygen carrying negative charge. Hence here the decreasing order of the acidic strength is most acidic is paranitrophenol, then phenol, then among these two, this is more acidic in nature because only one alkyl group is present. Here 3 alkyl groups are present. Because destabilization due to plus I effect. Okay, so this is your order 4, 3, 1 and 2. Then you can use your brain and try to find out the answer of this question. What are the electronic effects exerted by dash OCH3 and dash Cl, and predict the acidic strength of CH3O C6H4OH and Cl dash C6H4 dash OH. Means what is the name of this compound, identify the names and as compared to parent phenol. So write down the name and give me the answer in your next class. So this is about the acidic character due to breaking of OH bond. The next property is the ester. So let us see formation of ester from this alcohol and carboxylic acid. The process is called as esterification. So this esterification is carried out in presence of concentrated sulfuric acid, because if it doesn't use the concentrated sulfuric acid, reaction is reversible. So reactant, that is alcohol and carboxylic acid, gives ester as a product and water, and this ester again react with water, that means it undergo hydrolysis to give carboxylic acid and alcohol back. So this is a reversible reaction. To avoid this reversible reaction, to get ester as a product, we have to use concentrated H2SO4. So alcohol, see the reaction, alcohol react with acid, ROH react with RCOH. So reaction is reversible to give ester and water. Again this water react with ester to give acid and alcohol back. So to avoid this backward reaction, we have to use concentrated H2SO4. Then we get only ester and water as a product, because this concentrated H2SO4 react with water and it acts as a dehydrating agent. It removes that water from your mixture. So we get only ester in your reaction class. So how this reaction takes place? So this RO minus will attack on carbonyl carbon, this is carbonyl carbon, and the hydrogen of alcohol and OH of acid get removed as a water. So remember this, don't remove the OH group of alcohol and hydrogen of acid to give water. So this was studied by kinetics. If we label this oxygen with its radioactive isotope, then we observe that this oxygen is present in your ester. Okay, so remove the hydrogen from alcohol and OH from acid. Remember this. Then similarly, when phenol react with acid, it gives ester of that aromatic alcohol, aromatic compound, and water is the byproduct. So what is the difference here? Here R means alkyl group is present, and here AR means aryl group is present. This ester can be prepared. Instead of using acid, we can use anhydride. So in acid, COOH functional group is present, and if we add two acid molecules together, then dash C double bond O dash C double bond O, this compound is formed, and that is called as anhydride. By removing the water molecule from two acid compound, we get a anhydride. That anhydride can also be react with your alcohol, and it gives ester and acid. You see the box again, hydrogen of alcohol and RCOO minus of your anhydride gives RCOH, and remaining is the R dash CO from your anhydride and OR from your alcohol to use ester. Similarly, you can write the reaction of phenol, so it is aromatic ester. Instead of this anhydride, we can use acid chloride to form this ester. So what is acid chloride? RCOCl. So that is acid chloride. It can also react with alcohol and phenol. Again, same is the process. Hydrogen is removed from alcohol and Cl is from ester to give Cl from acid chloride to give ester, or hydrogen of phenol and Cl of acid chloride gives HCl, and remaining is the ester. So acetyl derivative means CH3CO group, that is called as acetyl derivative, or it is also called as acetyl group. So for example, salicylic acid, or it is also known as, write number COH carbon is carbon number 1, OH is 2. Why? Because COH functional group has first priority, OH has second priority. So it is 2-hydroxy benzoic acid. It is also known as salicylic acid. React with acetic anhydride. So hydrogen of this and CH3COO of acetic anhydride get removed as acetic acid, and the acetyl group is attached to this oxygen. So what we get? We get a acetyl salicylic acid. It is also known as aspirin. Then remaining reaction that you already learned in the previous topic, reaction due to breaking of CO bond. So if we react HCl, HBr and HI with alcohol, then we get a alkyl, chloride, bromide and iodide respectively. That reaction that you already learned in halogen derivative. Or reaction with phosphorus halide PX3 and PX5, that also you learn in halogen derivative. And dehydration of alcohol to alkene, that you learn in 11 standard. So that also we revise. in set zip rule discussion. So this is about the reactions.